Hi, good evening. So we went over the theory of the projectile, and in today's lesson, we'll be going over a few of the examples related to the projectile. So one of the examples we have is a gun that is aimed horizontally at a target 60 meters away, but the bullet hits the target 8 centimeters below the aiming point. So the initial position of the gun is horizontal, so the bullet is going to get a horizontal velocity of something. We do not know. That is what we are supposed to find out. So we do not know. So it is aiming a target that is at a distance of 60 centimeters, right? So there is the target, and the distance to the target from the point where it has been shot is 60 meters, not 60 centimeters, sorry, 60 meters. The bullet hits the target 8 centimeters down. So we know that in projectile, due to the gravitational acceleration that is pulling any objects in the downward direction, the object always get accelerated in the downward direction. So the bullet is supposed to hit at the horizontal level, but it hits 8 centimeters down. So we will convert everything to meters to eliminate any mistakes in the substitution in the equation, because when you are substituting in the equation, you have to substitute in the same unit, otherwise you will make mistakes. So I have converted it to meters, so it is 0.08. Now the questions are find the time of flight and its speed, and we are supposed to take g as 10. So we know that the gravitational acceleration is pointing always downwards, and in projectile there is no horizontal acceleration because there is no horizontal force. So these are the parameters we know. So what we can do is, do we know how long? We do not know. All right, so this projectile has two motions, right? So one is the horizontal component or horizontal projection with a velocity of v, which is the horizontal velocity itself, and it reaches that point, and the distance it has traveled is 60 meters. And the acceleration in the horizontal direction is going to be 0. So I'm going to mark it as ax equal to 0. Meanwhile, it has a vertical component as well. For the vertical component, the initial velocity is 0 because initially it was shot such that it only has a horizontal velocity. So it comes down with a vertical velocity, and the distance it has traveled is 0.08. And the acceleration due to gravity during that motion is 10, right? Sorry. There's 10. So I'm going to use the vertical component or vertical projection. For the vertical projection, I'm going to use the equation delta y equals to vit plus half at squared, and I'm going to use it in the downwards direction. So the displacement is downwards, which is 0.08. Initial velocity is 0 plus half. Acceleration due to gravity is 10 and t squared. So there is going to be t squared equals to 8 divided by 100, which is 0.08, times 2 divided by 10, which is 16 divided by 1000, right? So t is going to be 4 divided by 10 root 10. Or you can simply put that in your calculator and you can get the answer. So it is, give me a minute. It is square root of 16 divided by 1000, which is 0.1264. So it's 0.13 seconds. So that's going to be the time of flight. Then we are supposed to find the initial velocity. So I'm going to use the horizontal projection for that, right? So horizontal projection would be, and I'm going to use the same equation. So delta x equals to vit plus half at squared in the horizontal direction. So displacement during that period is 60, initial velocity is v, time is 0.13, and there is no acceleration in the horizontal direction, so I can find velocity as displacement divided by the time, which is 60 divided by 0.13, which is 461.5. So that is the horizontal velocity or the initial velocity, the time it was shot. All right. If you have any doubts, take it down. Sorry, ask, otherwise take it down and let me know.